Hey, this is Bobby. I'd like to share with you an easy, non-programmatic workflow to geocode and visualize attribute data on a map using a simple table in Google Sheets and the Geocode by Awesome Tools plugin. I'll start the geocoding process so you can see how easy it is to execute and what it looks like when it runs. But to keep the video short, I've duplicated the data on another table to work with it right away. The data set has 234 points in Maryland and Alabama. So I've geocoded all 234 addresses. The plugin utilizes the Google Geocode tool, which codes at approximately 1 row per second. So keep that in mind when you go to larger data sets of 50,000 or greater. I'll visualize the data in Google Earth using an xlsx to KML converter tool online. The tool is great because it doesn't require any code to use. It outputs a KML file or Google keyhole markup language file that could be opened directly in Google Earth. And lastly, I'll quickly demonstrate how easy it is for someone with a little experience to visualize the data in QGIS, an open source GIS that's free to use for everyone. So let's get started. I have the Google Sheet here. I have 1, 2, 3, 4, 5 rows, unique ID on the first row, the address in the second row. So click up on add-ons. You'll have to go to get add-ons, and then you'll type in Geocode. But I've already got Geocode by Awesome Table. It's right here. You'll just click on free, add it. It doesn't cost anything to use it. So it's added. Let's go ahead and use it. So go add-ons, Geocode by Awesome, start geocoding, and then over here it's going to recognize that this is the current sheet, sheet 3. The address column is address, and that's right here. That's correct. Then easy. I'll just go ahead and geocode. It moves over 2 columns, creates a latitude and longitude column, and begins the geocoding process. Now this is taking a little faster than 1 second at a time, and I believe that's because I just ran it. It's cached, so it has that data readily accessible. So let's go over to the completed sheet, which is the exact same data. I have just already completed this, so all the lat longs are here right now. Again, I have 2 states on here, Maryland and Alabama, just for the sake of having random data. I didn't control that. So we will go to, gotta find my guy here. Okay. So what I'm going to do is, sorry to bounce around here. I'm going to download this as a Microsoft Excel SLX or xlsx, and that's going to the download folder. So here, this is earthpoint.us. The URL is going to be located in the email. Easy to use. So comes up, you want Excel to Google Earth, choose File, simply choose the geocoding example xlsx that we just downloaded, open it up, and view on Google Earth. It's going to download the KML right here. If you have Google Earth installed, you can easily just click on it. If you don't have Google Earth installed, it is a very quick open tool that you can just go download for free. So this is a fast, open visualization platform. So you can roll in, you can actually click on the data, and notice how it carries over all the fields, which is super cool. So you don't lose fields when you do this. So you see the unique ID, the address, lat long, and then the example coded fields 1 and 2 with null values. So that's how you visualize data. And if you want, you can always go in and go to properties, and you can change the pin if you'd like in Google. Easy to do that. But you can play with the data in there. So this is open. This isn't for somebody that's in geospatial. So say we want a map and we want to create a quick heat map and a choropleth map to visualize our data a little bit more professionally. I'll show you how to do that real quick. And if you guys ever need help doing something like this, it takes me just a matter of minutes to put this stuff together for a reasonably sized data set. So again, here is the table. I'll open up QGIS, which is right here, and I've got a base map. I dig the black base map with the US Admin 1 boundaries, which are the states, and US Admin 2, which are the counties. So I'm going to go ahead and I'm going to create a new layer, add delimited text layer. Then I'm going to browse to geocoding example. I might need to save this as a CSV, we'll see. I do. Great. So I will go back to here. This is the Google Sheet again. I'm going to download as CSV. There she goes right there, and show in folder. I've got it off screen. I've got the 2 screens here, so this is the guy I'm going to go for. So view details. Open back up QGIS. Go to layer, create layer, add layer rather, delimited text layer. Then I will browse to that, the most recent one I put in there. This is it right here, geocoding example CSV. So open that guy up. Okay, there it is. So it recognizes all the fields, and it automatically recognizes X field, longitude, Y field, latitude. So what this is doing is it's taking non-spatial data, recognizing the lat long, and then converting it into spatial data, putting it on a map, and using a standard projection for the globe. So it's uniform to the Google's WIGS 84 projection. That probably doesn't mean anything to you. It just means that it's spatially accurate to Google and to the web. So we'll click OK, and boom, there you go. That automatically generates points on a map in QGIS. Now you can save this map as an image, a high resolution JPEG. We can add a legend to it, make it look real nice. We can put a title up on top, a north arrow, and a scale bar. So that's all the stuff that I do whenever I make a map, because I'm a geospatial guy, and it's a kind of code for us to do that. All right, so cool, we have the points here, but one more thing we probably want to do is show some better data. So with that, what I've done here is I've taken those points and I created a quick heat map from those points. Now this is what you want to see. So notice how when you zoom in and out, you get a different layer that's produced. This is called a raster. So as we zoom in, there's your data. But we want to take this to the next step. We can click on this data as well. So if I click on a point, it pulls up over here in the ID pane, the unique ID, the address, the same fields that we had in the table. So it recognizes, just like the KML, all those fields. But we want to go one further. So I have the counties on here. All the counties are stored in a geospatial table. So wouldn't it be neat if we were able to tell the counties that were impacted the worst with these events? Now, these events have no description other than the sample data you saw, but just imagine their crime. So you would look at this immediately and go, oh, yeah, this is a high crime area. So let's turn this into a choropleth map. And I'll just walk through really quickly, or talk through how I did that. I just isolated the county layers within the state of Alabama. And then I did a count function which counts all the points inside each polygon and then summarizes that. And then I displayed the counties by color depending on the amount of points within each polygon. That is called a choropleth map, and that's this guy right here. So we'll clean it up a little bit. There's your choropleth map. And this is great when you're showing polygon data. Again, you can make a map out of it with a legend, a scale bar, north arrow, and a title. And if you want to see the points over top of that, there you go. You can see the heavier hit areas are darker red, while the lighter areas are not so bad, sparse to 1 point populated. And we can change that easily. Go to properties here and pick a random color. We'll just apply that. You can change colors pretty easily. So if there's something that you want to see in a specific color in a map and you want me to visualize it for you, it'd be no problem for me to do that. So if you guys have any questions, please let me know, and thanks for watching.